In Ionic Lewis, the cation has how many valence electrons? So important thing to note, after I have declared it the cation, I have already transferred my electrons, and in ionic, the cation will have 0 valence electrons. It has none left. In Ionic Lewis, the anion has how many valence electrons? Important thing to know is after it is the anion, I have already transferred my electrons. And after the transfer, all of my anions are going to have 8. They're going to have their octet that they've always wanted. In Ionic Lewis, the anion has to be inside of what? With the what on the outside. So my anion is going to be inside of brackets, and its charge is going to be on the outside of those brackets. In Ionic Lewis, charges can or cannot touch, like charges can or cannot touch, so the cation or the anion must touch the anion. So like charges cannot touch, which means that my anion has to be in contact with a cation. I have to have opposite charges touching. I need to touch the person that I stole from. Draw out the Ionic Lewis structure for CaCl2 and answer the following questions below. So first, since I have the formula, I can just go directly to the correct amount of each calcium. Calcium is Ca. It is in column 2, which means it's going to have 2 valence electrons. Chlorine is in column 7. It means it has 7 valence electrons. So I'm going to go ahead and I'm going to give everybody their appropriate amount first. Then I'm going to go ahead and transfer those electrons. So I'm going to transfer away from my metal toward my non-metal, and then redraw my structure, making sure that my like charges do not touch. So I'm going to rearrange who I had where. I'm going to redistribute my electrons. Chlorine had 7, but it worked very hard to steal so that it would have 8. So I'm going to make sure that chlorine has 8. Since chlorine stole, I'm going to put it behind brackets, put it behind bars, put it in jail, and put its charge on the outside. It stole 1, so it has a charge of -1. Calcium had 2 electrons in the beginning, but it has since given them away, so now it has 0 valence electrons. And it gave away 2, and giving a gift is a nice thing to do, so it's going to have a charge of +2. There are / is blank number of chlorine ions present. So I have 1, 2. So I have 2 chlorine ions present. Each chlorine has blank number of dots and a charge of blank. So each chlorine has 8 dots, and it has a charge of -1. There is / are how many calcium ions present. There is only 1, so I'm going to say that there is 1 calcium ion present. Each calcium has how many dots? It has 0 dots, and has a charge of +2. Draw out the Lewis structure for Be3N2 and answer the following questions below. Since I have the formula, I can just go ahead and draw out the exact correct number of each, so I'm going to do that. Be is beryllium. Beryllium is in column 2, so that means it has 2 valence electrons. So I'm going to go ahead and distribute 2 dots to each of my berylliums. Nitrogen. Nitrogen is in column 5, which means it has 5 dots, so I'm going to give each nitrogen 5 dots. Okay, and I'm going to go ahead and start distributing electrons to from my metal to my non-metal. So I'm going to find empty spaces for those electrons to go. Since it already gave me the formula, it gave it to me in a very nice way, where I ended up with the perfect amount of everything. So all of my electrons have been transferred away, all of the empty spaces have been filled. Now I just need to redraw the structure and make sure that my like charges are not touching. So I'm going to just go ahead and alternate beryllium and nitrogen, because I think that that would be the easiest thing to do. But as long as you have like charges not touching each other, you're basically golden. So beryllium had 2 electrons, but it transferred both away, so it's going to have 0 dots, and I'm going to give it a charge of +2 to all of them, since it gave away 2 electrons, and giving a gift is a nice thing to do, and it gave away 2, so it has a charge of +2. Nitrogen had 5 in the beginning, but it just worked really hard to steal 3 so that it would have 8, so I'm going to make sure that nitrogen has the 8 that it worked really hard to get. Okay. Since nitrogen stole things, I'm going to put it behind bars, put it behind brackets, and then I'm going to put its charge on the outside. It stole 3 electrons. Stealing is bad, so it's going to have a charge of -3. Now I can go ahead and answer my questions. There are how many nitrogen ions present? 1, 2. Each nitrogen has 8 dots and a charge of -3. There are 1, 2, 3 beryllium ions present. Each beryllium has started with 2, but in my final form I have 0. And a charge of +2. Draw out the ionic dot structure for RB3P and answer the following questions below. So since I have my formula, I can just go ahead and draw out the correct number of each atom. RB is rubidium. Rubidium is in column 1, which means that it's going to have 1 valence electron, so each rubidium gets 1 dot. And P is phosphorus. Phosphorus is in column 5, which means it has 5 valence electrons, so it's going to get 5 dots. And then I'm going to go ahead and start transferring my electrons from my metal to my nonmetal. So I'm going to go ahead and do that. I'm going to find empty spaces for those electrons to go and get their new home. All of my electrons have been transferred, and phosphorus has all of its empty spaces filled, so that means that we are good to go. And I just need to rearrange this so that none of my like charges touch each other. I'm going to do it like this, but as long as you have your like charges not touching each other, it doesn't matter what the arrangement is. Rubidium had 1 dot, but it transferred away, so I'm not going to draw any dots on rubidium. And it gave away 1 electron. Giving a gift is a nice thing to do, so each rubidium has a charge of +1. Phosphorus started with 5 dots, but it worked really hard to steal 3 of those. So I'm going to give phosphorus all 8 electrons that it worked oh so hard for. But since it stole things, I'm going to put it within brackets, and I'm going to put how many things it stole, which was 3 electrons, on the outside. And since stealing is bad, we have a charge of -3. There is one phosphorus ion present. Each phosphorus has 8 dots and a charge of -3. There is 3 rubidiums, and each rubidium has 0 dots and a charge of +1.